Hello friends, once again welcome to chemistry classes by Vijay Kumar Sethi. Class 11th chemistry, we were discussing unit 7 equilibrium, and in this video we are going to discuss numerical based on Ka and Kb. First of all, problem 7.18. The ionization constant of HF is 3.2 into 10 to the power minus 4. Calculate the degree of dissociation of HF in its 0.02 m solution. Calculate the concentration of all species present, that is H3O plus, F minus and HF in the solution and its pH. Three things we have to calculate. We have to calculate degree of dissociation. We have to calculate equilibrium concentrations of all these species, and we have to calculate pH. Let us see how can we calculate. This is the equation representing the ionization of HF. HF plus H2O converting into H3O plus F minus. If initial HF is 1, then H3O plus will be 0, F minus will be 0 when no ionization is taking place. If alpha is the degree of ionization, then at equilibrium HF remains 1 minus alpha, H3O plus becomes alpha, F minus becomes alpha. If C is the concentration, then equilibrium concentration of HF is C 1 minus alpha, equilibrium concentration of H3O plus is C alpha, equilibrium concentration of F minus is C alpha, and C is given, that is 0.02. So we can write this is 0.02 1 minus alpha, this is 0.02 alpha, this is 0.02 alpha. Now write Ka. Ka is equal to concentration of H3O plus multiplied by F minus divided by concentration of HF, and this is equal to C alpha square divided by 1 minus alpha. Now Ka is 3.2 into 10 to the power minus 4. This is given. C is also given 0.02, and we have to calculate alpha. So alpha is equal to 0.12. Okay. In this case, you can also use the approximate method. That is, if we ignore alpha in the denominator, then we can find out alpha easily. Okay, that in that case this alpha becomes square root of, that is Ka by C. Okay, we can use this formula. So we will get alpha is equal to 0.12. Now with the help of this alpha, we can find out the equilibrium concentrations. So equilibrium concentration of H3O plus will be equal to F minus. Okay, and this is equal to C alpha, this one. Put the value. C is 0.02, alpha is 0.12. If we multiply, we will get 2.4 into 10 to the power minus 3m. In the same way, equilibrium concentration of HF, this is C 1 minus alpha. Again put the values and solve it. We will get 17.6 into 10 to the power minus 3m. Now to find out pH, formula is pH is equal to minus log of hydrogen ion concentration. And we have find out this hydronium ion concentration. Hydronium ion concentration and hydrogen ion concentration is the same. Okay, so this is 2.4 into 10 to the power minus 3. Put this value in this. So we will get minus log of 2.4 into 10 to the power minus 3, and if we solve it, we will get 2.62. Okay, to solve the log, please see my video how to solve log and anti-log. Next, problem 7.21. The pH of 0.004 m hydrogen solution is 9.7. pH is given. Okay. Calculate its ionization constant Kb and pKb. Now we can write this is the ionization process. NH2 plus H2O converting into NH2 NH3 plus. This is hydrogenium ion. Okay. Plus OH minus ion. Now from pH we can calculate the hydrogen ion concentration. We know pH is equal to minus log of hydrogen ion concentration. So we can write that is log of hydrogen ion concentration. This is equal to minus pH. Okay. Now if we want to find out only hydrogen ion concentration, then we have to remove log of this. In that case we have to take the anti-log of this side. So we can write hydrogen ion concentration is equal to anti-log of minus pH. Okay, this one. Put the value of pH. and solve with this antilog, you will get 1.67 into 10 to the power minus 10. Now we know the hydrogen ion concentration, and by this formula, that is Kw is equal to concentration of hydrogen ion and multiplied by concentration of hydroxyl ion, we can find out the hydroxyl ion concentration. Okay, so hydroxyl ion concentration is equal to Kw divided by hydrogen ion concentration, and Kw, that is ionic product of water, this is 10 to the power minus 14, and hydrogen ion concentration we have already calculated. Put the value and find out and solve it. That will be equal to 5.98 into 10 to the power minus 5, and this concentration is also the concentration of hydrogenium ion, that is NH2NH3 plus. Okay, how? Because according to this, so if we see the stoichiometry of this equation, there is the 1:1 ratio of hydrogenium ion and OH minus ion. So concentration of OH minus ion will be equal to concentration of hydrogenium ion. The concentration of both these ions is very small, so the concentration of the undissociated base can be taken equal to 0.004 m. Now we can write Kb, this is equal to concentration of hydrogenium ion multiplied by concentration of hydroxyl ion divided by concentration of hydrogen. Put the values. Okay, so we will get, actually concentration of both these species is the same, so we can write 5.98 into 10 to the power minus 5 square divided by 0.004 and solve it. 8.94 into 10 to the power minus 7, this is Kb. Okay, now using this Kb we can find out Pkb. Pkb is equal to minus log Kb. Now put the value minus log 8.94 into 10 to the power minus 7, and if we solve it we will get 6.05. Now problem 7.22. Calculate the pH of the solution in which 0.2 m NH4Cl and 0.1 m NH3 are present. The pKb of ammonia solution is 4.75. With the help of this pKb, first of all we will find out Kb. So pKb is equal to minus log Kb. Kb is equal to anti-log of minus pKb. Put the value of pKb and solve it. We will get 1.77 into 10 to the power minus 5. This is Kb. Now if we can say this ionization equation can be written like this: NH3 plus H2O converting into NH4 plus OH minus ion. Now initial concentration of ammonia is given, this one 0.1 m NaH, so this is 0.1. Now initial concentration of NH4Cl is given, and when this NH4Cl is dissociated, this will give NH4 plus. So concentration of NH4Cl concentration of NH4 plus ion is the same as that of concentration of NH4Cl. So this one concentration of NH4 plus is also 0.2, and when no dissociation is taking place, no ionization is taking place, the concentration of OH minus ion is 0. Now if change in concentration to reach equilibrium, it means when we can say X mole of NH3 converted into NH4 plus and OH minus ion. So we can write this is the change in concentration of NH3 minus X. At the same time, X mole of NH4 plus will be formed and X mole of OH minus ion will also be formed. Clear? So equilibrium concentration of NH3 is 0.1 minus X. Equilibrium concentration of NH4 plus is 0.2 plus X. Why? Because 0.2 is already present, and this X is coming from ionization of NH3, and equilibrium concentration of OH minus is X. Now again write Kb is equal to concentration of NH4 plus multiplied by concentration of OH minus ion divided by concentration of NH3. Put the values. Concentration of NH4 plus is 0.2 plus X. Concentration of OH minus ion is X. And the concentration of NH3 is 0.1 minus X. And solve it. We will get solved. This is equal to Kb, which is this one. 1.77 into 10 to the power minus 5. Now in this case, actually this Kb is very small, so we can neglect X in comparison to 0.1 m and 0.2. So we can write this expression can be written this one. Okay. Now in this case, we neglect this x. So 0.2 multiplied by x in the numerator. In the denominator, again we neglect this x. So only 0.1. And this is equal to 1.77 into 10 to the power minus 5. And if we solve it, we can find out the value of x, which will come 8.85 into 10 to the power minus 6. Now what is this x? X is this concentration of hydroxyl ion. Okay, so this is OH minus ion concentration. Now if we know the concentration of hydroxyl ion, with the help of ionic product of water, we can find out the concentration of hydrogen ion. So concentration of hydrogen ion is equal to Kw divided by concentration of hydroxyl ion. Kw is 10 raised to the power minus 14, and concentration of hydroxyl ion we have calculated, and if we solve it, we will get 1.13 into 10 to the power minus 9. Now concentration of hydrogen ion we have calculated. With the help of this, we can find out pH. So pH is equal to minus log of hydrogen ion concentration. Put the value and solve it. We will get pH is 8.95. Okay. Now problem 7.23. Determine the degree of ionization and pH of a 0.05 m of ammonia solution. The ionization constant of ammonia is 1.77 into 10 to the power minus 5. Also calculate the ionization constant of the conjugate acid of ammonia. Okay. First write the ionization equation. NH3 plus H2O converting into NH4 plus OH minus ion. Initial concentration same way. This is 1, then this is 0, this is 0. If alpha is the degree of ionization, then equilibrium concentration of NH3 1 minus alpha, NH4 plus alpha, OH minus alpha, and if C is the concentration, then we can write equilibrium concentration of NH3 is C 1 minus alpha, equilibrium concentration of NH4 plus is C alpha, equilibrium concentration of OH minus ion is C alpha. Okay, then again write Kb. What is this Kb? Base dissociation constant or base ionization constant. Kb is equal to concentration of NH4 plus multiplied by concentration of hydroxyl ion divided by concentration of NH3. Put the value. This C alpha concentration of NH4 plus. This is C alpha concentration of OH minus ion, and this is C 1 minus alpha. This is the concentration of NH3. This C is cancelled by C, so we will get C alpha square divided by 1 minus alpha. Now again, we can neglect this alpha in comparison to 1 in denominator. So we will get Kb is equal to C alpha square. And with the help of this, we can find out alpha is equal to square root of Kb by C. Put the value. Kb is 1.77 into 10 to the power minus 5, and C is 0.05, which is given in the question. And if we solve it, we will get 0.018. This is degree of ionization. Clear? Now we have to find out the pH also. So hydroxyl ion concentration is C alpha, and as we know, C is given, alpha we have calculated, and if we solve it, we will get 9.4 into 10 to the power minus 4. With the help of this hydroxyl ion concentration, we can find out hydrogen ion concentration. This is equal to Kw, ionic product of water, divided by hydroxyl ion concentration. Again, Kw is 10 to the power minus 14, and concentration of hydroxyl ion we have calculated, and if we solve it, we will get 1.06 into 10 to the power minus 11. With the help of this hydrogen ion concentration, we can find out pH. pH is equal to minus log of hydrogen ion concentration. Put the value and solve it. We will get 10.97. Okay. Now we have to also calculate the ionization constant of conjugate acid of ammonia. And that equation, conjugate acid of ammonia is NH4 plus. So by using this relation between K and Kb, Ka into Kb is equal to Kw, we can find out the ionization constant of the conjugate acid of ammonia. Okay, in this case we have to find out Ka. Kw we know, 10 raised to the power minus 14. Kb we have calculated 1.77 into 10 to the power minus 5. So Ka is equal to 5.64 into 10 to the power minus 10. Okay, thank you.